Okay, this is Math 2, Mr. Trutna, Clovis High School. These are the solutions to Worksheet 3, numbers 7 through 10, and numbers 17 through 21. Remember, after watching the video, to smash that like button. So, random thought to ponder for the day. If glue is sticky, why doesn't it stick to the inside of the jar and make it impossible to pour or squeeze out? Okay. So, number 7 through 10, we are finding the value of x in these problems. So the strategy is, when we're solving an equation and we're solving for the value of x, there's a couple things that we have to do. Our first step is, we always want to make sure all the parts of the problem are in exponential form. So I'm going to take this first part right here, and I'm going to change this into exponential form. So the radicand will become the base, and then my exponent will become the numerator, and then my index will become the denominator. Okay, then I'm going to multiply this, and I'm going to change this radical into exponential form as well. So this will become 15 to the 6th force power. Okay, I don't have to change the 15 to the x over 4 power. So whenever you're solving for x, the first thing you want to do is everything has to be in exponential form. Then after you do that, you want to cancel out the bases, but you can't cancel out the bases until there's a 1-to-1 base ratio. You can see I have 2 bases here to the left of the equal sign, but only 1 base to the right of the equal sign, so I have a 2-to-1 ratio. So what I'm going to do is, I'm going to combine these 2 bases together into 1 base, and I'm going to use the product rule that says I can combine these into 1 base by adding the exponents up. So I'm going to add the 3/4 and 6/4 up, and then that's going to be equal to 15 to the x over 4. Now when this happens, if we have a 1-to-1 base ratio and the bases are the same, the bases cancel out, and what you're left with becomes your equation that you're going to use to solve for. So you can see I am left now with 3/4 plus 6/4, and that's equal to x over 4, and I solve this equation. I add 3/4 to 6/4, that is equal to 9/4, and that's going to be equal to the fraction x over 4. And then since both of these denominators are the same, they will cancel each other out. So in number 7, x is going to have to be equal to 9. Okay? Moving on to number 8. The first part of this equation, remember, I have to have everything in exponential form. So I'm going to change the cube root of 25 to the 2nd power into the exponential form as 25 to the 2/3 power. Times, I don't have to change 25 to the 4/3 power, that's already in exponential form, and then I don't have to change 25 to the x power. Okay, now once I do that, I have to have my bases in a 1-to-1 ratio. So I'm going to have to take these 2 bases here, 25, and I'm going to have to combine them together to make it 1 base of 25. And I'm going to do that by using the product rule, which says I add the exponents together. So I'm going to add the 2/3 and the 4/3 together, and that allows me to combine the base. Then that's going to be equal to 25 to the x power. Okay, now when I do that, the bases are, because they're the same and they're in a 1-to-1 ratio, they will cancel each other out, and then that leaves me with the equation 2/3 plus 4/3 is equal to x. Adding up 2/3 and 4/3, that's 6/3. That's going to be equal to x, and we could just simplify this. 6 divided by 3 is 2. So that answer for number 8, my value for x is going to be 2. Okay? In number 9, I have 7 to the 4/3 power. I'm going to leave that in exponential form, but then I have to convert the index of 9 of the radical of 7 to the 6th power into 7 to the 6/9 power. Okay, and then that's going to be equal to, and I'm going to leave 7 to the x over 3 power like it is, because I need to have everything in exponential form. Then, after I get everything in the exponential form, once again, I need to set up my equations so I have one base on each side of the problem. Now, my equation has one base on the right side of the equation, so I'm not going to change the 7 to the x over 3 power, but I'm going to combine these two exponential expressions together into one base of 7. Now, I'm going to be able to do that by doing the quotient rule, which says I can combine the bases into one base, but I have to subtract the exponents. So I'm going to have to go 4/3 minus 6/9. Okay, now when I do this, these 7s would cancel each other out. They're the exact same base, and there's only one of each one, so they cancel out. And then I'm left with my equation that I'm going to use to solve for x of 4/3. Now I'm going to do a little slick little thing right here. I'm going to divide this 6 over 9 by 3. I'm going to reduce it to 2/3. 6 divided by 3 is 2. 9 divided by 3 is 3. So I'm going to get 4/3 minus 2/3 is equal to x thirds, or x over 3. 4 over 3 minus 2 over 3 would be 2 over 3. That would be equal to x over 3. And since these denominators are the same, they will cancel each other out, which makes my solution for x to number 9 as x is equal to 2. Okay, number 10. My first strategy is I need to change everything into exponential form. So 5 to the 4/3 power is already in exponential form, but then I'm going to change this denominator into 5 to the 2/6 power, and that's going to be equal to 5 to the x power, which is already in exponential form. Then remember, once I do this, once I change everything in the exponential form, then I need to rewrite this left side of the equation as having just one base of 5. In order to do that, I'm just going to combine these two 5s together to give me one base of 5, but I can do that only if I subtract the exponents. So I'm going to have to go 4/3 minus 2/6, and I'm going to leave the 5 to the x alone. Okay, now when I get to here, the 5s would cancel each other out because they're the same base, and we're in a 1-to-1 ratio. And then I'm just, whatever I'm left with, I'm going to work out to solve for x. Now once again, I'm going to reduce this 2/6 by dividing by 2. So this problem is going to become 4/3 minus 2 divided by 2 is 1. 6 divided by 2 is 3, and that's going to be equal to x. I write what I have left. 4 over 3 minus 1 over 3 is 3 over 3. That's going to be equal to x. 3 over 3 just means 1. So in number 10, x is going to be equal to 1. Okay? All right, moving it over to the other side, you were assigned numbers 17 through 20, and in numbers 17 through 20, what we're doing is we are going to be simplifying each expression, and we're going to write the final answer using only positive exponents. Okay, so in number 17, the first thing that I'm going to do is I am going to rewrite the problem I'm going to rewrite it using only positive exponents first, okay? So I'm going to keep the 3, I'm going to keep the 21 for now, and now the x to the minus 5 means I have to move that to the bottom to make it, or the denominator, to make it x over 5. The x to the negative 8 power means I can rewrite it from, since it's on the denominator, I move it to the numerator as x to the positive 8 power. The y to the negative 2 means I'm going to put y to the positive 2 on the denominator, and the y to the negative 9 means that I'm going to put y to the positive 9 on the numerator. Okay, so now once I have nothing but positive exponents, I'm just going to use my properties of exponents to simplify. So the first thing I do is I take the 3 over 21, and those are the coefficients, so I actually reduce that. So 3 over 21 reduces to 1 over 7, And then I'm going to take the exponents that have the same base and I'm going to subtract. Because when I divide, I subtract. So I'm going to take the x and then I'm going to simplify it. I'm going to have to subtract 8 minus 5. And then I'm going to do the same with the y's. I'm going to take the y's and then I'm going to subtract 9 minus 2. Simplifying that out, I know that I'm going to have a 7 on the denominator. And then on the numerator, I don't have to write a coefficient of 1. I'm going to have x to the 3rd power, y to the 7th power. And that would be my simplified version of number 17. Okay, number 18, I'm going to do the same concept of number 17. Before I try to simplify, I'm just going to rewrite the problem so that I have nothing but positive exponents. Okay, so rewriting this, the negative 8 is going to stay on the numerator. It's a coefficient. It's okay for it to be negative. That w to the negative 9 power, I'm going to put on the denominator as w to the positive 9. W to the negative 2, I'm going to move to the numerator, but it's going to become w to the positive 2 power. And then the x to the 3rd and x to the 2nd, I could leave them where they're at because they are already positive exponents. Okay, now I'm going to simplify this problem. So when I simplify it, there is nothing to divide or reduce with negative 8, so I know I'm going to have a negative 8. And then I'm going to take the w's that have the same base and I'm going to subtract their exponents, 2 minus 9. I'm going to do the same with the x's. I'm going to subtract the exponents, 3 minus 2. Okay? Now you can see right now I have nothing on my denominator for my final answer. And that might stay the case. So I'm going to have a negative 8. W to the negative 7. 2 minus 9 is negative 7. X to the positive 1. Okay, so that's what I get after I simplify. Now, whenever we simplify a problem, we cannot have negative exponents in my answer. So that means I have to move the w to the denominator, and it gives it a positive 7. But I leave the negative 8 and the x where it is. So number 19 would simplify to negative 8x over w to the 7th power. Okay, number 19, first thing I do when I simplify it is I'm going to rewrite the problem so that there are no negative exponents, and then I'll simplify them. So I'm going to leave the negative 7 alone. I'm going to leave the a to the 3rd where it is. I have to move the b to the negative 8 to the denominator to make it b to the positive 8. I'm going to leave the 28 where it's at. I have to move the a to the negative 7 to the numerator, so it'll become a to the positive 7. And then I have to move the b to the negative 12 to the numerator, and it's going to become b to the positive 12. So the first thing that we want to do is we want to move everything around so we have nothing but positive exponents. Then we're going to follow the rules of exponents to simplify. So simplifying this out, I take my coefficients and I reduce them, okay, by dividing both of these numbers by 7. So I'm going to get negative 7 divided by 7, that's negative 1. 28 divided by 7 is 4. Then I'm going to take the a's, which have the same base, and I'm going to add the exponents up. Because when I multiply exponents that have the same base, you add the exponents. Then I'm going to combine the b's that have the same base, but I'm going to subtract the exponents. Okay, simplifying this out, I get a negative 1, a to the 3 plus 7, that's 10, b to the 12 minus 8, that's 4, and that's all going to be over 4. So that's going to be number 19. Okay, and then the last assigned problem on this worksheet was number 20. So first thing that I'm going to do in number 20 is, actually the last one was 21. So the first problem that I'm going to do in number 20 is, I'm going to notice I have no negative exponents, and that's good, but I have a 0 exponent. So if you have a 0 exponent, rewrite the problem without 0 exponents. So that means when I rewrite this, simplify it, The 3n squared will stay where it's at. And then this 5 to the 0 power would just make that part of the problem 1. The 0 power turns it into 1, and then I have 4n to the 3rd power. Okay? 1 times 3 is really just, I can multiply these together, that's really just 3. So now to simplify this, I cannot simplify 3/4, so I'm going to still have a 3/4 in my final solution. And then I'm going to take the exponents of the same base, which is n, and I'm going to subtract the exponents. So that's going to give me 3n, 2 minus 3 is -1 over 4, and I can't have a negative exponent in my solution, so I'm going to have to take the -1, which is attached just to the n, and I'm going to have to move that to the denominator. The -1 will become a +1, which I don't have to write. So that would be number 20's simplified version. Okay, moving on to number 21. You notice I have a -4 as an exponent. So the first thing that I want to do in this problem is I want to rewrite the problem so that it has no negative exponents. Now, this -4 is for the entire inside parentheses, so that means we have to change everything. So the m to the 2nd power has to get moved up to the numerator, and the 2m to the 4th power has to get moved up to the, or moved down to the denominator. And when I do that, that changes that -4 power into a +4. Okay? So I just rewrote the problem without negative exponents. Now I'm going to take this outside exponent of 4, and remember, it applies to everything on the inside of the parentheses. So that outside exponent of 4 applies to the m squared. That outside exponent of 4 applies to the 2, and it also applies to the m to the 4th power. Simplifying this out, I'm going to use the power rule, which says I'm going to multiply these exponents together. So that gives me m to the 8th power. 2 times 4 is 8. Then I'm going to simplify 2 to the 4th power. That's 16. 2 times 2 times 2 times 2. That's 2 to the 4th, which is 16. And then I'm going to multiply these 4's together to make m to the 16th power. Okay? Now I'm going to simplify this problem even further. I'm going to first work with my coefficients. So my only coefficient is 16, so I know I'm going to have a 16 on the denominator. And then I'm going to combine the m's together by subtracting the exponents, 8 minus 16. So now my problem becomes m to the -8 on the numerator and 16 on the denominator. And once again, I cannot have a simplified answer with a negative exponent. So I have to move this m to the -8's to the denominator. So I'm going to put it right next to the 16, but the m becomes +8. But now I have to put a 1 on the numerator. So that's my simplified version of number 21.